Hi guys, my name is Dasun. So I'm gonna do the chemist 1 tute from our community LivePhysics. So let's start with question number 1. Uh, the number of lone pairs of electrons around oxygen atom in an H2O molecule is. So we know that the H2O molecule looks like this when drawn, right? So this bond pair represents 2 electrons. So the questions ask how many valence electrons are around oxygen atom. So if we count these lone pairs, it's gonna be 1, 2, 3, 4, 5 and 6. So here question number 1 answer is gonna be 3, 6 lone pairs of electrons around oxygen atom. Question number 2. Chemical formula of the carbonate of an element M is M2CO3. What is the chemical formula of chloride of M? Right, this is an easy one. M2CO3. Right? If we separate this one into 2 groups, this is 1, right? We know it's carbonate, right? Check this. We have an table that says a lot of names of polyatomic ions. This is M2 plus. Sorry, M plus. So the question asks, what's the formula of chloride of M, right? We know that chloride ion has a charge of -1. Like we did here, we're gonna do the opposite of this one. We have an M plus ion. So in O levels we have a method called interchanging method. It's not an official method, but we use it to make things easy in here. I repeat, this is not an official method, right? We interchange the ions. I hope you guys know it by now. So it's gonna be M chloride. Okay, so answer is gonna be 1. Question number 2, answer is 1. Question number 3, the number of protons in an aluminium 3 plus ion are respectively. Okay, I'm gonna clean up here first. Question number 3. We know aluminium is 13th element in the periodic table, right? So that means we can extract the data that aluminium has how much protons. We have 13 protons in a normal aluminium element. Okay. The number of electrons. So they ask aluminium 3 plus, not aluminium. So we know that in normal aluminium the number of protons is same as the number of electrons, right? But here in the question they ask aluminium 3 plus, not aluminium. So in an ion, basically plus means they have emitted electrons out. So 3 plus means they have the aluminium element has ejected 3 electrons. So if we consider this situation as the initial situation and this as the later, it means that since we have 13 electrons initially and the aluminium 3 pluses has emitted 3 electrons further, we have 10 electrons here. So to the answer to the question is 1. It has 10 electrons and 13 protons. Usually the number of protons does not change whatever the ion it becomes. If we take oxygen O minus, O2 minus, these 3 ions have the same number of protons. I repeat, same number of protons. Only the number of electrons can be changed. An additional point, since we got plus here, it means we have emitted 3 electrons. But here, minus, it means that this oxygen atom gained 2 electrons. Right? I hope you guys can remember this. Okay, question number 4. Question number 4. What is the standard notation of tritium? Tritium. So, what is tritium? Your textbook has this. I mean, if you guys read it, you must already know about it. I hope you guys read it about it. So, tritium is an isotope. What is an isotope? Same element, different number, protons? Nope, it's neutrons. This is a basic definition you guys should know in your O-levels. So, tritium. Tritium is an isotope of hydrogen. Hydrogen has 3 isotopes. First one is the hydrogen you guys know. Then we have tritium. Then we have another one called deuterium. So here we have the same number of protons but different number of neutrons. Basically, another additional point for you guys, protons, neutrons and electrons. These are the basic subatomic particles in an atom. Neutrons and protons are normally in the nucleus. Not normally, they are in the nucleus. Electrons orbit around the nucleus. They orbit. And hope you guys know this. Protons are positively charged. Then we have electrons, which are negatively charged. Then what about neutrons? Neutrons doesn't have a charge, so no charge, I guess. You guys should know about this. Okay, moving on. The answer to that question is, by the way, is answer number 1. You guys should read about these. These are normal points that will be questioned in your paper. Like it's mostly remembering stuff. Okay, question number 5. Consider the following chemical reaction. zinc sulfate plus X. We have X sulfate plus zinc. Okay, chemical reactions. We have types of chemical reactions, right? I'm gonna go two types here. We have single displacement reactions, then we have double displacement, and two more. You guys should know these. Read them. Gonna go over these. So here we have an what type of reaction? Is it double or is it single? Zinc sulfate plus X sulfate plus zinc. So I'll teach you guys how to differentiate between single displacement and double displacement. Here we have zinc 2 plus to be exact, but you guys don't need to know about those right now. We have zinc here. So this X kicked out zinc. X kicked out zinc out of sulfate, and X came into sulfate and bonded. So here X acted as only single entity. So it kicked out zinc, bonded with sulfate, and zinc became all alone. So basically zinc became single. So we know it's a single displacement reaction. But for you guys to understand it more clearly, I'll give you a double displacement reaction. Like we'll have zinc sulfate again react with something like magnesium carbonate. So here basically what happens is magnesium kicks out zinc out of sulfate and zinc kicks out magnesium out of carbonate. So we'll have something like magnesium sulfate plus something like zinc carbonate. This is not an official reaction, but I wrote this so you guys could have a clear understanding about double displacement reaction. So this is a single displacement, this is double displacement. Okay. Sorry, the question asks which following elements could. So you guys have a thing called let me erase these thing called reactivity series, right? So here magnesium is more reactive than aluminium, and what else is there? Zinc, ferrous, and copper. So in the for this X to kick zinc out, X has to be more reactive than zinc. So we have two elements which are more reactive than zinc, which is magnesium and aluminium. So if X was magnesium, then he could kick out zinc. If X was aluminium, same as zinc, it could kick out zinc. But if it was iron or copper, they can't kick out zinc because they are more weaker in reactivity than zinc. So in order for displacement reactions to occur, one element has to be more reactive than the other one. So X can be either magnesium or aluminum. Let's see if we have magnesium or both actually. Second answer is aluminium, and we have third one magnesium, but the most suitable answer would be magnesium, as it is more reactive than magnesium. So answer is going to be 3, magnesium. Okay, answer for question number 5 is number 3, magnesium. Moving on to question. The structures of the hydrides of the three elements X, Y and Z are given here. Which elements in the table represented by X, Y and Z? Okay, let's see. Number 2, right? So yeah, for you to understand it, let me put it like this. Question number 6, we have one Lewis structure like this, and another Lewis structure like this, and another one like this. Valency. Let's consider valency here again, guys. So if we consider valency here, we have how many? We have 2 lone pairs and 2 bonded pairs. So we have, like, if we consider electron wise, the electrons are divided as these. How many electrons does X have? 1, 2, 3, 4, 5, 6. 6 electrons. Meaning valency is number 6. I'm going to write valency here as 6. Yeah, if we consider same thing in the second structure, what's the valency number here? 1, 2, 3, 4, 5. Valence is 5. Here, what's the valency here? You guys should be able to tell this by now, hopefully. So the valency here is 1, 2, 3, 4. 4. So in the periodic table we have things called groups. We have 8 groups for you guys, but there's more in the future if you study chemistry more. Like, I'm gonna write up to hope it's clear. So here we have valence number, meaning this X atom should be able to withhold 6 electrons. So in which group which group has elements that can hold 6 electrons in their valence shell? Basically it's easy to remember, since it's gonna be group 6. They have 6 electrons in their valence shell. Valence shell means the last shell. Last shell is called valence shell. So it has like 6 electrons in its valence shell. So here how many group 6 elements? Only one, oxygen. So X has to be oxygen. We can get the answers now. It's number 2 already, but I'm gonna explain it further for you guys to understand even more. So if we consider Y has 5. 5 means group number 5. So Y has to be in group 5 element. We have only one group 5 element, nitrogen. Okay, it's gonna be nitrogen. X gonna be oxygen, and Z. It's gonna be carbon, my favorite element. You guys understand why it's my favorite in A levels? Hopefully, if you do it. So the answer is gonna be number 2. You can identify its answer number 2 from the, if you identify X first. So it's an easy one. Okay, moving on to question number 7. The number of electrons and the number of neutrons in the ion indicated by the symbol Na plus 2311 respectively are. This is another easy one. These are usually marks that you take from home. You guys will be lucky if you get questions like these for your paper. So in question number 7, Na plus 2311. This is how we denote an ion according to our UPAC standards. 11. If X is an element, we have a thing called atomic number. Z. Then we have mass number. This is how you denote mass number and atomic number according to IUPAC standards. This plus means it's an ion, so it can be either plus, minus, or it can be nothing. So in the question they ask the number of electrons and the number of neutrons in the ion indicated by the symbol. Okay, we know that mass number is number of subatomic particles in the nucleus. We have only 2 types of subatomic particles in the nucleus. That's proton, number of protons, plus number of neutrons. Then atomic number is like a thing like valency, but not the same thing. Atomic number is usually same as the number of protons, but if we consider an atom in its stable state, it is also same to the number of electrons as well. But for this to happen, the element should be in its stable state. What do you mean by stable state? We have ions. Na plus is an ion. This is an ion. What's its stable state? What happens if we put back the same electron back into sodium? So electrons are negatively charged. If we put a negative electron into sodium again, this plus disappears. This isn't an ion anymore. It's an element in its stable state. So normally how you write is in its stable state. So if you have minus or plus charges, it isn't in its stable state. But if you don't have charges, it's not. So here Na is not in its stable state. It has emitted an electron from its outer shell, the valence shell, and it has become an ion. So we know that it has sodium has the atomic number of 11, so it means it has 11 protons. But since we since we emitted one electron, yeah, let me explain it like this. When sodium is in its stable state, it has 11 electrons in its stable state, right? It pushed one electron out. I don't need you. It pushed its electron out. Okay, so if we push one electron out, we have 10 electrons. So this thing has only 11 electrons, 10 electrons in its shells. So we have two answers that says 10 electrons, 2 and 3. So we have to find the number of neutrons. Oh, that's an easy part. We know that number of protons is 11. If I take the number of neutrons as x, mass number is given as 23. It's a basic math stuff. So let me take it here. 23 minus 11, 2, 1, 12 neutrons. The answer is going to be 3. 8. What is the true statement about neon 20 and Na plus? Answers number 3. I'm not gonna explain it. It's the same thing as here. You guys find it out. The answer is number 3. It's the same stuff if you refer to the marking scheme. It's the same thing. Not gonna waste your time here by doing 8. So I'm gonna move to question number 9. What is the pair of subatomic particles which attract each other? So I told you guys electrons have a negative charge and neutrons are neutral, and protons have a positive charge. So neutral cannot attract anything, so it has to be positive and negative. Only positive and negative attract to each other. So it must be answer number 2. Easy one. Electrons and protons. Question number 10. The electronic configuration of the atoms of two elements X and Y, 281 and 287 respectively. Which statement is false? Okay, this is another easy one. X, Y, 281, 287. Yep, 287. It's the same stuff as before. We need the periodic table here. I'm gonna label it quickly. So how can I put it? Okay, here this number, like usually when we represent this in the standard notation, these are number of electrons in each shell. So both X and Y have 3 shells, and the last part represents the valence shell. So X has 1 electron in its valence shell, and Y has 7 electrons in its valence shell. So to have this 3 subshells, both X and Y have 3 subshells, meaning they are in period number 3. So both of them has the same period. But when it comes to group number, they have different group numbers. We can sort it out from here. If we look here, this has 1, this has 7. So Y belongs to group 7, X belongs to group 1. So the false statement should be answer number 2, located in the same group in the periodic table. Okay. Question number 11. W, X, Y, Z are 4 elements consecutively placed in the periodic table with atomic numbers below 20. In which group periodic table is Y placed? Okay. I'm gonna teach an easy method so you guys can, so you could guys. Question number 11. For you guys to remember the ionization variation of any group, I'm gonna teach you this method. So imagine this is group 1. Okay, group 1 elements ionization energy. So when we go to group 2, it climbs up. Okay, then when it goes to group 3, it goes down little bit, not as much as group 1 but a little bit down. Then when it comes to group 4, it goes up again, and when it comes to group 5, it goes up again. When it comes to group 6, it's not gonna go up again, it's gonna go down again, little bit higher than group 4 but a little bit lower than group 5. So when it comes to group 7 and 8, it's gonna go up again. So for you guys could remember this like 2 ups, 1 down, 3 ups, 1 down, 2 ups again. Like remember this pattern, so it will make things easier. So this is group 1, group 2, group 3, 4, 5, 6, 7 and 8. So we have a down pattern and 1 up and a down again. So another thing, when we move down a group, it starts from the bottom up. Like this is the group number 8 from the previous period. Like if I consider this to be neon, this could be sodium, right? So in the paper, a pattern like this is shown, right? Like we isolate this part, I mean it's basically the same stuff. So why is gonna be group 2? Yep, why is gonna be group 2? The easiest thing for you guys to do for a question like this is remember the pattern. This pattern will make the question easier and you guys could save time. So for question number 11, answer is gonna be 2, group 2. Question number 12. What is the metal that reacts with hot water but not with cold water? Okay, this is common knowledge when it comes to A levels, but since you guys are doing O levels, I'll teach it. The only element that's not gonna react with cold water but hot water is gonna be magnesium. Like the only element we have that reacts with hot water, steam, but not with cold water. Every other element reacts with both cold, hot and steam. So it's a theory part. Answer gonna be 2, magnesium. Like this is a question you should know. Like don't write all levels if you don't know this one. Okay, question number 13. Select the correct statement given about atoms. The nucleus of all the atoms of every element contains neutrons. Okay. In every atom, the number of neutrons and the number of protons in the nucleus are equal. Nope. I told you that like 3 times before, not every atom has the same number of neutrons and protons. Basically it's isotopes. Okay, statement number 3, the atomic numbers of two atoms of different elements can be equal. No. Basically atomic number is a unique thing to that element. Statement number 4, there may be atoms with different mass numbers in the same element. Yep, that's what we call an isotope, guys. So statement 1, I didn't explain that before. The nucleus of all the atoms of every element contains neutrons. No. Basically I told you about the isotopes of hydrogen, right? One isotope of hydrogen called protium doesn't have neutrons. So yep, statement number 1 is wrong, only statement number 4 is right, so answer is gonna be number 4. Question number 14, the second most abundant element in the earth's crust. Same thing as question number 12, it's theory. You guys should study theory. So shows 3 statements to identify the question. Answer shows semiconductor properties, metallic properties, as well as non-metallic properties. The answer is gonna be silicon. One more thing, aluminium. Aluminium is the most abundant metal on the earth's crust. That's another point you guys should know, right? Okay, boron and phosphorus are not in your syllabus, right? Not much in depth. Okay, moving to question number 15. So as I said before, question number 14, the answer is going to be silicon. Question number 15, what is the statement that is true with respect to all molecules given below? CO2, ammonia and H2O. Yeah, the first one is the answer. Let me explain it. CO, if we do draw the carbon dioxide's Lewis structure, we have gonna have something like this. When it comes to ammonia, something like this, and H2O, as you guys should know, is like this. What the common thing that all these 3 Lewis structures has is they all have a complete octet. What does an octet mean? So octet means that it has 8 electrons in its valence shell. So you guys should know that one line shows 2 electrons, right? These electrons are shared between both nitrogen and a hydrogen atom. So if we take electrons that affect nitrogen, both these electrons affect nitrogen. So if we're gonna take the octet, we are gonna have 8. Okay, so with this 1 2 3 4 5 6 7 8, we have a complete shell. The last shell has 8 electrons, but 3 electrons are shared between both nitrogen and the 3 hydrogen atoms. Okay, so same thing here. We have 2 electrons which is shared between carbon and oxygen. So if we count it, we have 1 2 3 4 5 6 7 8. Same thing here, 1 2 3 4 5 6 7 8. So statement number 1, all these 3 have complete octet. So answer is gonna be 1. So that's gonna be the end of the first part, and the rest of the questions will be discussed by someone else. So look at these types of questions, like 2 or 3 questions is gonna come from things like this. Good luck, guys. Hope you enjoy your paper.